Hi, my name is Abhimanyu Singh, and this will be my project for AI Product Management course. In this project, I will be predicting electrical energy output using Google Auto ML. In this model, the matrix I will be using is MAE, which is mean absolute error, and RMSE, means root mean squared error. I'm using these two metrics because these zero that will be considered our model to be more accurate. And also, our MSE is more responsive to large errors than MAE. So that's why I'm using RMSE in this. In this model, I'm using these features which was provided to us in the data sets. So also, I divided the data set to 80 to 20 ratio, in which 80% of data will be using to train our model and 20% will be used later to test our model. So in this model, the features we will be using is our average temperature, which will be AT, ambient pressure, AP, relative humidity, RH, exhaust vacuum, V. And I'm using PE, which will be electrical energy output, as our target value. Our model will be trying to predict the value which is will be closer to the targeted value, which will be given here. And in input parameters, I divided data sets in three different input parameters to determine which possible feature we may want to use in the model, and also to identify the different algorithm we might consider. So in first data set, I'm carrying all four features to train our model. In second data set, I'll be carrying two features, which will be average temperature as AT and ambient pressure as AP to train our model. And in third feature in data set, I will be carrying exhaust vacuum and relative humidity as V and RH to train our model according to that. So I divided my data set according to that, as you can see in this Excel sheet. In the first model, I trained the model using all these data features. In second model, I use AT and AP to train our model. And in third model, I used these two features, V and RH, to train our model. So here, this is our model number one, which I already trained uh, using AutoML. And these are the values I'm getting. For MAE, I'm getting 2.709, and for RMSE, I'm getting 3.454. So the closer the value to zero, the more accurate our model will be considered. So in model number one, I'm getting these values. In model number two, I'm getting these values, as you can see here, 3.712, and as RMSE matrix, after using that, I'm getting 4.715. And in model number three, I'm getting these value when I train the model using V and RH. I'm getting MAE as 5.46 and RMSE as 7.123. So let's test our models according to that. So here we go. We'll wait for it to deploy. So here, these are the data we have. So let's test our model. So first, take AT, then V, then AP, then RH. So once I click on predict, the value must be closer to our PE, which is our targeted value. So once we click on predict, it will give you our prediction value. which is 430.30, which is again closer in this our predicted value, which is much closer, which we can see in this. So let's see, test our second model. In this second model, we are using AT and AP as a feature to test our model and see how accurate the value is. As you can see, I've already tested it multiple times to see how accurate the value is. And again, I will do it again. AP. And once I click on predict, it should provide us the value, which is 407.38, which is again closer, but not that much as model number one. Okay, let's see what our model number three gives us. So let's deploy. I already deploy and tested it, so I'm doing it again. So here we are taking V to test it and RH here, and then click on predict. And we will see our model is predicting the value 3434.12, which is close, but not that much as our model number one. As you can see, we have already tried that multiple times. And this is what we are getting in all three models. So as you can see, as I evaluate all three models, we can see that even if when we run the test, when we first run the model, all three models, we are getting, when we evaluate the models, we are getting these values. And we will consider model number one as a success because uh, model one is providing a prediction, accurate prediction we will consider because it's providing values closer to zero than the other two models. And that's why model number one we will be using for further testing. And here I will conclude my presentation. Thank you.